Hello everyone, I hope you are doing well. So in this video, I'm going to walk you through some of the problems in homework 3 and homework 4 of introductions to linear algebra. So let's jump into homework 3. So there are 7 problems in homework 3s, and homework 3 basically focus on the application of system of linear equations. So we did some example in class where we have a bunch of points and we want to fit a curve or a polynomial functions into those points. And so that's the idea for homework 3. So let's start with problem 1 and see what happened. So in this problem, you have a polynomial functions of the form f of x equal to axq plus px squared plus cx plus d. And you want to find the form of this polynomial functions given the point that x equal to 0, y equal to -1, which is the first point right here. The second point is x equal to 2, y equal to 1. The third point is x equal to -4 and y equal to +5. And the last point is x equal to -5 and y equal to 7. So you have 4 points and you want to fit a polynomial function of degree 3, always 1 less than the number of points that you have. So again, let's do the setup for problem 1. So problem 1. So what I want to do is I want to find the polynomial of the form ax cubed plus bx squared plus cx plus d given 4 points, right? So f of 0 equal to -1 means that you have the point of the form 0, comma -1. F of 2 equal to 1, meaning that you have the point 2, comma 1. The third point is f -4 equal to 5, or this is -4, comma 5. And the last point is f of -5 equal to +7, or you can write in the form of order pair, that is -5, comma 7. All right, so to find value of A, B, C, and D, what you do is you substitute this point into the functions and you will obtain a system of 4 linear equations because you have 4 points. All right, so let me start with the first point. All right, so substitute this point, right? So 0, comma -1, 2, comma 1, -4, comma 5, and -5, comma 7 into f of x. All right, so in your homework, you may have a different number than the number you see here in my in my setup. All right, because all of this number are randomized. All right, so substitute the first point 0, comma -1 into the functions you get. So f of 0 equal to a times 0 cubed plus b times 0 square plus c times 0 plus d, and that is equal to the output, which is -1. So you have the first equation. Now the second equation should be f of 2 equal to a times 2 squared, 2 cubed plus b times 2 squared plus c times 2 plus d equal to +1. The third equation is a times -4 cubed plus b times -4 squared plus c times -4 plus d equal to +5. And the last point give you f of so this is f of -4 for the third equations and f of -5 for the fourth equation. So this give me a times -5 cubed plus b times -5 squared plus c times -5 plus d equal to +7. So that's the setup for system of 4 linear equations. Of course, you can always solve this system by hand, but there's another way, much faster way to obtain the value of A, B, C, and D. That is to plug in to Python and use Python to help with the calculations, right? So before doing that, I'm gonna turn this into an augmented matrix. So the augmented matrix of the system is, right, so here's the setup. Right, so you're gonna have so A, B, C, D are the variables that you need to find. The coefficient matrix going to be sorry, so 0, 0, 0, 1. Why is 1? Because the coefficients of D is 1. And on the right hand side of the vertical line is -1. All right, so that's the first equation. The second equation is 2 cube and then 2 square, then 2, then 1, then the constant value is 1. For the third equation, you obtain -4 cube, -4 square, -4, and I don't need parentheses here, but it's -4, and this is 1, and this is 5. The last equation give me -5 cube, then this is -5 square, this is -5, this is 1, and this is +7. All right, so these are the values that you need to input into Python, right? If you notice, you can see that I didn't work out the calculate the value for 2 cube or -4 cube or -5 cube for that matter, because I don't want to, for some reason, miscalculate that in my head. So what I do is I keep the same form and just input this number into Python and let Python do the calculations. All right, so now let me switch to Python and see what happened. So this is the screen, and I'm going to modify the code, and you have this code already in class. So 0, 0, 0, 1, and the last entry should be -1. Get rid of this. Now for the second row of the augmented matrix, I have 2 cube, right? And then 2 square, then 2, then 1, and then +1. The third row give me -4 cube, then -4 square, then -4. The next entry is 1, and the last entry is 5. Now for the last row, I have -5 cube, -5 square, -5, 1, and +7. Now let it run and see what we have here. All right, so I get that A is equal to 19 over 420, B is equal to 71 over 140, C equal to -41 over 210, and D is equal to -1. So, so from Python, I get that A is equal to 19 over 420, B is equal to 71 over 140, C is equal to -41 over 210, and D is equal to -1. And then for my answer, I'm gonna input the functions of this form. Now the form has A to be 19 over 420, B equal to 71 over 140, so on and so forth. All right, so let me do that. So 19 over 420 x cubed plus 71 over 140 x squared, right? X squared minus 41 over 210 times x, and then minus 1. Now let's check the answer and see what happened. All right, so that's the process to obtain the value of a, b, c, and d given the polynomial function of degree 3 to fit into 4 given points. All right, so now let's move on to the next problem. So problem 2. All right, so the setup is going to be the same, right? So now instead of polynomial function of degree 3, now you have 4 polynomial function of degree 4 because you have 1, 2, 3, 4, 5 points, right? You're gonna go through the process just like we did in problem 1 and then fit that into come up with the system of linear equations and transform that into an augmented matrix, and then input the augmented matrix into Python and let Python do the calculation for you. That is the intention for this exercise. My intention is not for you to solve this system of 4 linear equations or 5 linear equations by hand, right? It's just ridiculous to do that by hand. And using Python is a lot faster and more practical for us. All right, so that is problem 2. Again, very similar to problem 1. Now for problem 3, again, very similar to the last 2 problems. You have a quadratic functions that is polynomial function of degree 2, and you're going to use this to fit into 3 points, 1, 7, 2, 17, and 3, 5. You go through the process again. You have 3 points. You substitute 3 points into the functions, and you have a system. You will have a system of 3 linear equations. Turn the linear equations into an augmented matrix, and then input that into Python and let Python do the calculations for A, B, C. Okay. Problem 4. All right. So this is a little bit different from what we have done in the last 3 problems and also in class, but the setup shouldn't be too difficult for us to figure out. So this is problem 4. So the sum of 2 integers is 69, and the difference of the same numbers is -11. Find the 2 numbers. So the setup is that you have 2 integers, right? So you just say that, okay, let 2 integers to be x, y, right? So we let 2 integer be x and y. And the information given to us here is that the sum of the 2 integer is 69. That is x plus y is equal to 69. And the difference of these 2 numbers is -11. That is x minus y equal to -11. Okay. And you can actually solve for x and y from here. Again, you can turn this into an augmented matrix and ask Python to do the calculation for you, or you can actually do this by hand if you want to. All right, so this system is easy enough for us to do the calculations by hand. So I noticed that I have a system of 2 linear equations. So I noticed that if I add these 2 equations together, the variable y get canceled out, and so equation 1 plus equation 2 give me 2x. Again, the positive y and negative y value cancel out, and you left with 2x equal to 58. So that is 69 minus 11, give you 58. To find the value of x, you divide both sides for 2, and you get 29 for the value of x. Now, to obtain the value of y, you back substitute x equal to 29 into either equation 1 or equation 2. So back substitute x equal to 29 into equation 1. Again, either equation should be fine. So I get 29 plus y equal to 69. And therefore, y is equal to 69 minus 29, give you 40. So the numbers, the two numbers are 29 and 40. So I'm going to put this in my answer. So let's submit the answer and see what happened. So that's the procedures that you need to follow. All right, so that's problem 4. Let's move on to problem 5. So for problem 5, again, the setup is that you have two numbers, the sum, that means x plus y equal to -1, and the difference, that is x minus y equal to +7. Can you actually do the setup and do the calculations? Again, it's very similar to problem 4, but let me do the setup here. So you have two number x and y, right? So the sum is that x plus y equal to -1. The difference is x minus y equal to +7. Now, can you do the calculations just like we did in problem 4 to get the value of x and the value of y, or in this case, the largest of the two numbers, the smallest of the two numbers. Again, should be very similar to problem 4. Now for problem 6, right? Now, problem 6, similar to problem 1, 2, and 3. So problem 6. In this case, they ask you to use the quadratic polynomial functions, that is polynomial functions of degree 2, to fit the 3 points given to you, right? Y quadratic, y polynomial function of degree 2, because it's always 1 less than the number of points that you have. And the quadratic polynomial functions, right? Quadratic functions is of the form. Right, so f of x equal to ax squared plus bx plus c. And you substitute the 2 points given to you into this formula to obtain a, b, and c. Okay. Again, the intention is not for you to do all the calculations by hand. You set up the system of linear equation, turn that into a augmented matrix, and then input the matrix into Python and ask Python to do the calculations for you. Now move on to the last problem, which is problem 7. Again, very similar to problem 1, 2, 3, and 6. In this case, you have polynomial functions of degree 4 to fit into 5 points, right? And let me write down the polynomial functions of degree 4 for you. So polynomial of degree 4 is of the form f of x equal to ax to the 4th power plus bx cubed plus cx squared plus dx plus e, right? So you have 5 points. You substitute this into the functions, these functions. You will obtain a system of 5 linear equations. Again, turn that into an augmented matrix, input the augmented matrix into Python, and you can obtain the value of A, B, C, D, and E. Okay. All right, so I hope this video give you some idea on how to do homework 3. I have another video for a walkthrough for homework 4. Okay, please let me know if you have any questions on homework 3.